couple of nights ago you watched a screencast on solving inequalities, and in particular at the end you talked about compound inequalities, dealing with and or. So today we're going to have an extension of that, and we're going to talk about absolute value equations and inequalities. So first we're going to talk about equations. First of all, we know that absolute value is how far the number is away from 0 on a number line. So if I say that the absolute value of x is 5, then I know that x has to be either 5 or negative 5, because those are the two numbers that are 5 spaces away from 0. This number right here, this number represents how many spaces away from 0. If the absolute value of something is 5, then it is 5 spaces away from 0. So the absolute value of what is 5? Is the absolute value of 5 is 5, and the absolute value of negative 5 is also 5. So we can use this in order to solve any absolute value equation. For the absolute value equation, the absolute value of ax plus b is equal to c, then that means that this number right here, whatever ax plus b is, whatever that number is, has to be c or negative c, because this number is how many spaces away from 0. C spaces away from 0. So the only two things that are c spaces away from 0 are c and negative c. So let's look at some examples. This is the first example. The absolute value of 2x minus 5 is equal to 9. So we know that this number right here inside the absolute value sign has to be 9 spaces away from 0, because if the absolute value of something is 9, this 9 represents, remember, how many spaces away from 0. So what two numbers are 9 spaces away from 0? Well, think about it. On the number line, 9 is 9 spaces away from 0, and negative 9 is also 9 spaces away from 0. So we write two equations. We say that 2x minus 5 has to be equal to 9, or 2x minus 5 has to be equal to negative 9. Now, we always write two equations with absolute value equations, because how many ways can we be 9 spaces away from 0? 2 ways. We go from the right or the left, so 9 or negative 9. So we solve our equations, and we see that x is either 7, or we see that if I add 5, I get negative 4 and negative 2. So two solutions. Two different solutions would make this sentence true. So a good thing to remember for absolute value equations is that you most likely will have two solutions. Okay, so we're going to look at one more example. We're going to add one before we go on to the inequalities. If we come across something like this, where the absolute value sign is not by itself already, like it was in the first example, the first thing that we want to do is get the absolute value sign by itself before we write our two equations. Let me repeat myself. The first thing we want to do before we write our two equations is we want to get the absolute value sign by itself. So we're going to subtract 5 first, before we say that this number represents how many spaces away from 0. Away from 0. So we want to say that 1/2 x, so now we're going to write two equations. We're going to say that 1/2 x has to be equal to 5, or 1/2 x has to be equal to negative 5. Because what two numbers are 5 spaces away from 0? Well, 5 or negative 5. So whatever is inside the absolute value sign has to be 5, or it has to be negative 5. So x could be 10, or x could be, x could be negative 10. Two solutions. So we just remember that before we do anything, we want to get the absolute value sign by itself. Then that number on the right side represents spaces away from 0. One more thing before we move on to inequalities. Let me go to a new page. One more thing. Let's suppose that it said this here. Well, this, remember, number right here represents spaces away from 0. It says the absolute value of something is equal to negative 5. Well, how can we be negative 5 spaces away from 0? How can the absolute value of something ever be negative? It's not. So if we come across this, it's kind of like a trick. We would want to say no solution, because there's no way that the absolute value could ever be negative. Okay, now we're going to talk about our inequalities. Okay, so absolute value inequalities are always compound inequalities. I wonder why. Let's take a look at it. Okay, so it says that the it says that the absolute value of 2x plus 7 is less than 11. Okay, sorry. The absolute value inequalities. Okay, so it says that the absolute value of 2x plus 7 is less than 11. Remember, this 11 represents spaces away from 0. So, how many ways can we be less than 11 spaces away from 0? Well, if we look at a number line, here's negative 11, here's 11. Okay, if I am less than 11 spaces away from 0, I am anywhere in between 11 and a negative 11. Anywhere to the right of 11 would be greater than 11 spaces away from 0, and anywhere to the left of negative 11 would be more than 11 spaces away from 0. So, the only way that we can be less than 11 spaces away from 0 is to be in between 11 and negative 11. And what this makes me think is that we have an AND compound inequality, because AND is usually, most of the time, in between the two values. So we want to write two inequalities. We want to write a compound inequality. We want to write an AND compound inequality. We want to say that 2x plus 7 is less than 11 and 2x plus 7 is greater than negative 11. That is how we are less than 11 spaces away from 0. Less than 11 and greater than negative 11. So we're going to solve our two inequalities. 11 minus 7 is 4, and we get x is less than 2. And then we subtract 7 again, and we get negative 18. Divide by 2, and we get greater than negative 9. So we want to say that x has to be less than 2 and greater than negative 9. So this is the way we write it. We put the x in the middle, and we write one going to the right. It doesn't matter which one. One going to the right, it does not matter which one we write first. X is less than 2 and greater than negative 9, just like that. And if we want to graph our solution on the number line, we want to say, okay, if here's 0, there's 2, there's negative 9. We want to put open circles at 2 and negative 9 because we are not including 2 and negative 9, and you want to shade everything in between. Okay? Okay, so we're going to do another example now. We're going to do this one. Okay, so this one says that the absolute value of 3x minus 2 is greater than or equal to 18. Greater than or equal to 18. Absolute value is greater than or equal to. This 18, remember, represents how many spaces away from 0? So more than 18 spaces away from 0. Let's see it. Let's look at our number line. More than 18 spaces away from 0 is on the right side of 18, but we're going to include 18 this time because it says greater than or equal to. So anywhere here, here on this side of 18, and anywhere on this side of negative 18 is more than 18 spaces away from 0. So what we have here is an OR compound inequality. An OR compound inequality, oops. We have an OR compound inequality, and we're going to write that OR compound inequality now. We're going to say that 3x minus 2 is greater than or equal to 18, which counts for this part, or 3x minus 2 is less than or equal to negative 18, which counts for that part. Then we're going to solve our two inequalities. We get x is greater than or equal to 20 over 3, or we could say 6 2/3, or, let's see, now we're going to solve the other part. We're going to add 2 to both sides and get negative 16, less than or equal to, x would be less than or equal to negative 16 over 3, which is negative 5 1/3. And we would graph our solutions on the number line. Negative 5 1/3 is over here. 6 2/3 is over here. We want to put closed circles. We know that because we are including. And greater than or equal to 6 2/3, less than or equal to negative 16 over 3, or negative 5 1/3. Remember, when we're graphing an OR compound inequality, we always want to graph what we call the union of the two, which means we just put them together on the number line.